Hello and welcome. My name is Lichu Matthew, and I'm here to present my analysis on COVID-19 for the state of Illinois and United States. Also, welcome the head of Illinois Department of Public Health for joining this presentation. Before we begin, here are the three key statistics for this study. One, to perform an exploratory data analysis which involves identifying and collecting the data, identifying key statistics for this study and the features of time series data, then perform univariate and multivariate analysis and provide the forecast. These objectives are for both US and Illinois data. We have gone through the EDA part in our last presentation. Here are some key statistics, and the source of the data is from COVID tracking project. Here we can visually see for both US and Illinois that the total tests done are very high, deaths being very low, and positive counts are low when compared to the negative counts. A quick recap on positivity rate, which is widely used in decision making. It's the percentage of all the tests performed that are actually positive. High positivity suggests high transmission and likely more people not being tested. Low positivity simply means that the level of transmission is low relative to the amount of testing done at that point of time. So for this study, daily positivity rate would be a good statistic that represents the severity of the pandemic. While we plotted the data, we saw a non-stationary behavior for both US and Illinois data. Now on to univariate analysis. We first differenced the data, and for US, AIC5 identified ARIMA 511 and ARIMA 1412 as the top two models. For Illinois, AIC5 identified ARIMA 211 and ARIMA 412 as the top two models. We also see a seasonality of order 11, which we will explore. Here are the model comparisons. ARIMA 511 produced an ASE of 4.04 with a rolling ASE of 2.21. ARIMA 1412 produced an ASE of 2.07 with a rolling ASE of 2.27. Model 3, which is an MLP model with a diff order, produced an ASE of 5.49. And ensemble model, which is model 1 and model 2, produced an ASE of 2.95. So based on ASE, ARIMA 1412 was the chosen model. For Illinois, model 1 produced an ASE of 5.81 with a rolling ASE of 3.57. Model 2 produced an ASE of 5.735 with a rolling ASE of 4.03. MLP with lags produced an ASE of 25.66, and ensemble model, which is model 1 and model 2, produced an ASE of 5.73. So based on ASE, ARIMA P equals to 2, Q is equal to 1, D equal to 1, and S equal to 11 was the chosen model. Here are the short-term and long-term forecasts for both US and Illinois. US forecasts tend to mean because it's an ARIMA model. Illinois forecast shows slight decrease in positivity. Coming to multivariate analysis, the data set has 16 features. By plotting the data and identifying the correlations, we chose key factors: positive increase, negative increase, and death increase for our multivariate analysis. Here are the models. Here are the model comparisons. VAR model produced an ASE of 18.05, MLP produced an ASE of 6.02, and ensemble model produced an ASE of 11.77. And for Illinois, the VAR model produced an ASE of 76.96, and MLP model produced an ASE of 38.415, and ensemble model produced an ASE of 55.77. So based on ASEs for both US and Illinois, the chosen model was MLP. Here are the short-term and long-term forecasts forecasts show a very slight decrease in positivity rate. Here is my final conclusion. Univariate analysis models perform better based on the ASE and the rolling ASE. Forecasts from univariate and multivariate analysis show that the positivity rate is going to remain same or have a slight decrease. This tells that the strict measures should be taken to bring down the positivity rate drastically to contain the spread of virus. Thank you.